Hello, algebra students. We are in our last section that we will be covering in Chapter 6, and it is Section 6-6. And we've already talked about linear inequalities. Now we're going to put two inequalities together and form a system. So today is about systems of linear inequalities. And what I'd like for you to be able to do by the end of this lesson is to be able to graph these and then identify where the solution is, or the solution set is. So first of all, what is a system of linear inequalities? A system of linear inequalities is made up of two or more linear inequalities. So, for example, y is greater than x plus 3 and y is less than or equal to 2x minus 1. That would be a system. We have two inequalities in one problem. Now, where is the answer to these, or where is the solution? So, a solution, aka answer, solution and answer mean the same thing, of a system of inequalities is an ordered pair that makes all of the inequalities in the system true. So that all part is important. It can't just make one of them true, it needs to make all of them true. So what are the steps to this? This is going to be very, very similar to what we've been doing the past couple days. We're going to graph the boundary line by using y equals mx plus b. We've already done that. Then we're going to decide, is it dashed or is it going to be solid? So you're going to need to look at your inequality symbol for that. If it's dashed, it's going to be a less than sign or a greater than sign. If it's going to be solid, then it's going to say less than or equal to or greater than or equal to. So when there is a line underneath, then you make it solid, and when there's not a line underneath, you make it dashed. At that point, you're going to test an easy point to determine what side to shade on. So an easy point usually is 0, 0. There is one exception. You cannot use 0, 0 if it falls on the line. So 99% of the time this won't be the case, but there has been an example of two where the line did go through the origin, so we wouldn't be able to check it in that situation. But usually use the point 0, 0, plug it into your equation, and then determine, does that make the inequality true or false? And then you shade. So that was for the first inequality. Step 4 is you're going to repeat that, doing the second one. And finally, the solution or the answer is where the shading overlaps. And you're going to see what I mean by that on these examples on the next page. So let's flip this over and just jump right in. It says, what is the graph of the system? So let's do this first one. It says, y is less than 2x minus 3. So let's start graphing that. The negative 3 is my y-intercept, so I'm going to go down to negative 3. And then 2 is the slope. So I'm going to go up 2 over 1, up 2 over 1. I'm going to keep doing that. And then I can go down 2, back 1, just to have plenty. Now I need to determine, is it dashed or solid? Because this does not have a line underneath, I'm going to make it dashed. Now I need to determine, do I shade above or below? So I'm going to see, is 0, 0 right here, is that an answer? So I'm going to say 0 is less than 2 times 0 minus 3. That gives me 0 is less than 0 minus 3, or 0 is less than negative 3. So ask yourself, does that make this equation or inequality true? No, it does not. That is wrong. So 0, 0 is not an answer, which means I shade everything on the opposite side of that, which is going to be down here. And I'm going to do my best to make my shading obvious so it'll be more clear where they overlap. That's the goal, at least. Okay, we just graphed the first equation. Now let's graph the second. This is not in slope-intercept form. I need to subtract 2x from both sides, and then I'll just write it down here. That then gets me y is greater than negative 2x plus 2. Now I'm able to graph. So I'm going to go up 2 on the y-intercept, or on the y-axis, and then my slope is negative 2, which means I go down 2 to the right 1, down 2 to the right 1. Or up 2 to the left 1. Okay, now that I got my dots in, determine, is it going to be a dashed or solid line? This should be a dashed line because it's strictly greater than. So make that dashed. And finally, I need to shade. So I'm going to plug in 0, 0 into this inequality now. So this is going to be 0 is greater than negative 2 times 0 plus 2. Is that true? I have 0 is greater than 0 plus 2. 0 is greater than 2. No, that is not true. So this point right here, 0, 0, is not a solution to that inequality. So I'm going to shade on the opposite side of that, or up here. Now, where is my actual answer to this? My actual answer is this part where they are both overlapping. Notice how there are pink marks and green marks in this same area. If it's only pink, not an answer. If it's only green, not an answer. If there's no shading, not an answer. Only the part that's in both of them, because these answers will satisfy both of these inequalities. Let's do that again. So I have my two inequalities. They're both in slope-intercept form, so I can start graphing. The first one, my y-intercept is 4. So I'm going to go up to 4. And then my slope is 1/3. So I'm going to go up 1 over 3, up 1 over 3, or down 1 to the left 3. Because there is no line underneath, it's going to be dashed. And then I need to determine what side do I shade on. Well, I can easily plug in the point 0, 0, so let's do that. That's going to be 0 is less than 1/3 times 0 plus 4. Now 1/3 times 0 is 0, and 0 plus 4 is 4. So I have 0 is less than 4. Is that true? Yes, yes it is. So I am going to shade everything on the bottom side of this line. Because that's on the same side as the solution 0, 0. Okay, now let's graph my second inequality. Y-intercept is -2. Slope is 1/3, so up 1 over 3, up 1 over 3, or down 1 to the left 3, down 1 to the left 3. It is going to have a solid line because it is greater than or equal to. And let's plug in the point 0, 0. So that's going to be 0 is greater than or equal to 1/3 times 0 minus 2. 1/3 times 0 is just 0. And then 0 minus 2 is -2. So I have 0 is greater than or equal to -2. Is that true? Yes, both of those ended up being true. So now I'm going to shade on the same side as that point. So right here is where that point 0, 0 is. It is above this solid line, so I need to shade everywhere above that solid line. My solution set is going to be where they overlap and crisscross. So that's this section right in here, where there are both green and pink marks. So we're just going to keep doing that. It's just graphing and then looking to see where the shading is going to overlap. So very similar to the previous couple days in class. It's just now we're adding another equation and looking for overlapping shading. So let's do this one. Y-intercept is -2, slope is -2/3, so down 2 to the right 3, down 2 to the right 3, or up 2 to the left 3, up 2 to the left 3. It's going to be a solid line because it is greater than or equal to. And if I plug 0 in, then I have 0 is greater than or equal to -2/3 times 0 minus 2. In other words, this right side is going to be 0 minus 2 or -2. 0 is greater than or equal to -2. I believe that is true. Yes, 0 is more than a negative number. So here is where that answer is, 0, 0. It is true, so I shade everything on that side. So I am going to do that now. Shading everything on that side. There we go. Okay, now I want to graph the second inequality. So now I'm going to go up 3 because that's my y-intercept, and it has a slope of -2. So I'm going to go down 2 to the right 1, down 2 to the right 1. Remember, negative slopes are going to go downhill from left to right, so that's going to help us make sure we're going in the right direction when we're counting. And I made it a solid line because there's a line underneath of that inequality. Let's check the coordinate 0, 0 and see if that makes this line true. So that would be 0 is less than or equal to -2 times 0 plus 3. That means 0 is less than or equal to 3. Yes, 0 is in fact less than or equal to 3, so that one works as well. So now, whatever side of the line 0, 0 is, which is right here, compared to this line, I'm going to graph, or I'm going to shade everything on that side because it's the same side as 0, 0. Now I look for where my colors are overlapping, which is this section right here, and that's my solution set. So we're just going to keep repeating that in example B. My first inequality has a y-intercept of -5 and a slope of -1/2. And remember, slope is rise over run, so I rise -1 and run +2. So down 1 over 2, down 1 over 2. It's going to be a dashed line. And what does the point 0, 0 do? It says 0 is less than -1/2 times 0 minus 5, or 0 is less than -5. No, that is not true. So that means this point right here, 0, 0, is not an answer. So I need to shade on the opposite side of the line down here. Now, let's do the next one. I have y is greater than or equal to x minus 1. Okay, y-intercept is -1. People are trying to say that the slope is 0 here. The slope is not 0. Remember, there's an invisible 1 right there, so the slope is +1. It's going to be solid because it is greater than or equal to that line. I kind of missed every single dot there, but whatever. And let's check the point 0, 0. So that gets me 0 is greater than or equal to 0 minus 1. Is 0 greater than or equal to -1? Yes, it is. That one does work. So now I am shading everything on the same side as 0, 0. So I'm shading all of this part. The solution set is once more where the lines overcross. So that's this part right here. It is not where it is only green, it is not where it is only pink, and it is not where nothing is shaded. The only area where there are answers is where both sections are shaded and it's overlapped. We just have 2 more examples, and then we're done with this section of notes and chapter 6 as far as new notes go. First equation, y is less than negative 1/2 x plus 1. Go up to the positive 1 and then graph your slope of negative 1/2. So that part we've been practicing a lot, and you guys are pretty strong with that. Because there is no line, this one is going to be dashed. Let's check the point 0, 0. So that is 0 is less than negative 1/2 times 0 plus 1, or 0 is less than 1. Yes, that is true. So on the same side that 0, 0 is on, right here is 0, 0. So that means everything on that side is going to be an answer. Now we need to graph the other equation. This time I'm going to positive 1, and the only real difference is instead of a negative slope, it has a positive slope. So now I'm going to go up 1 over 2, up 1 over 2. Or down 1 to the left 2, down 1 to the left 2. Because it has a line underneath, it's going to be a solid line. Let's connect those. And I'm once again going to check the coordinate 0, 0. So this is 0 is less than or equal to 1/2 times 0 plus 1. Or 0 is less than or equal to 1. I agree with that one as well. So the same side of this line, this line right here is the one we're focusing on. This guy. The same side as 0, 0 is the side we're going to shade on. So all of that. Don't let the pink marks throw you off, because sometimes when you get a lot of things on one graph, it can get a little confusing. But make sure you're focusing on the right line. All right. So now we look to see where they are overlapping. They are overlapping in this area, so that is where our solution is. One more problem, and then we are done with these notes. So we have y is greater than negative x minus 3. I'm going to go down 3. The slope is negative 1, so that's down 1 over 1, down 1 over 1. Or up 1 to the left 1. This is going to be a dashed line. And we need to check and see if 0, 0 is a solution. So that would be 0 is greater than negative 1 times 0 minus 3. Or 0 is greater than negative 3. Yes, that checks out. So the side of the line that 0, 0 is on is right here. Because it is an answer, we do shade on that side of the line. Okay, let's do the same process with this next one. We go up to positive 3. And this has a slope of positive 5, so that means up 5 over 1. 1, 2, 3, 4. It'll be about here. My graph is kind of running out, but we can do the same thing just backwards. So down 5, 1, 2, 3, 4, 5, left 1. 1, 2, 3, 4, 5, and left 1. There we go. It's going to be a solid line. And I need to determine what side to shade on. It is close, but 0, 0 does not fall on the line, so I'm fine with checking 0, 0. So this is going to be 0 is greater than or equal to 5 times 0 plus 3, or 0 is greater than or equal to positive 3. No, that is not true. So this coordinate 0, 0 is not an answer to this line. If it is not an answer, then I shade on the other side, which that is over here. And I look for where the lines overlap, which is this section right there. All right, I hope that's making sense. Have a lovely evening and bring your questions to class.